Alright, get started here. This is NET-200. We're on week 6. This would be day 11, 10, 5, 16. Chapter 4, did the pre-assessment. Talked about topics, which we're going to in the screens that follow, and we worked on some labs. Big part of chapter 4 has to do with cables, and we talked a little bit about how when you have copper cables or some type of wire, you have to be concerned about interference. Less concerned with fiber, but there's also issues with wireless. We'll talk about those. Here we refer to a point-to-point. For example, Mercy here in Mason City has a headquarters over by Detroit, and they pay a service provider to create a point-to-point connection. So it really looks like these two are directly connected. Excuse me. And we're not really sure how the service provider might make the connection, but it does. They pay for what would be like a direct line connection between them. OSI model. We have all of these, I'll just call them apps, all of these applications that we talked about, like a browser connecting to a web page. We have email, and you can get email through a browser if you want to. We can download software. We can go to a secure web page or just a regular web page. All those things, apps allow you to do this. And in fact, any app that's going to connect into some type of network, we can use the OSI model to represent that. So the first layer in the OSI model is this link into the application. This isn't actually the applications, it's the connection to the apps. The apps are really separate. Next, we decide how we're going to present the data. Then we set up a session. For example, a browser connecting, going to connect with a web page, so a client to a server, maybe a client to a server. Then we figure out how we're going to transport the information. We create a segment. We can take and break the information into segments because we are limited on the size that we can send through the network. Okay. Next, we create a packet. A packet takes the segment and adds information onto it, which would be encapsulation. We find the path and we get an IP address. Transport layer, we decide if we're sending it UDP. We're not going to check the packets, we're just going to send them like streaming, or TCP, which is a typical web page connection where we'll transmission control protocol. We're going to keep looking until we get all the packets. IP routes us through the routers, and the data link and physical link, this links the devices together. We have that media access control. And we can talk about two major protocols here, 802.3 Ethernet, 802.11 Wi-Fi. Both very popular to connect the devices into the physical layer, the actual movement of the data on some type of media, fiber, wireless, or wired copper, coax. Wireless, there's different ways of wireless fiber through the glass tube. Then we get the bits of some electronics, some, however the wave is or whatever, to represent the bits on the other end. make the connection between the devices. Let's take a look at it more. A lot of busyness on the page. First of all, network interface card. Somewhere the device has a MAC address, often called a physical address. Actually, they use both terms. For example, we can connect to a device through a cable, an RJ45 jack, or they might have an antenna. Laptops typically have both. You could connect using fiber, not as common, maybe on servers, but that wouldn't be real common at this point. When we connect, we have some type of bandwidth at the interface, the pipe. How many bits do we connect with? A lot of devices now, 1 gig, 1 billion bits per second. And then if you connect to a switch that has a 1 gig port, then you can transport at that speed between those two. Now, just because you have this connection doesn't mean your performance is going to be good, because throughput depends on a lot of things between where the signal would leave, let's say a smartphone here, and actually get to a website here. There's a lot of factors in between those two. So let's just compare this. Let's start out with PCs in the classroom, copper to the switch, switch goes copper to the multi-layered switch, multi-layered switch is copper to the router, and then we have a fiber connection, and this is between different buildings to this router, and this router is fiber out, both of those. College has a firewall, be fiber between the buildings, and I know they have some high-speed copper connecting their servers and so forth. So we also have access points connected to the switch here, so we have the two ways to get in. You can get in through a RJ45 jack through copper, or some type of Wi-Fi antenna. Okay, two different protocols. Okay, similar but different. And outside of that, you could also connect using LTE to a cell tower, and from there they would get into the provider, and the provider can get you into the internet if that's what you want to do. So here we showed a smartphone connecting in through an access point, which then uses copper or fiber to get over to the multi-layered switch and then out. So we must recognize too logical, physical topology. Sometimes we draw primarily logical, sometimes we draw physical. This is the design on how things move out. Logical, typically logical would have the IP addressing. It doesn't have to, but typically it have the IP addressing. Physical, typically not. And if you get really technical, physical would show everything. More or less every wire connection to every port. So we've got a PC, and it connects to that little box in the classroom. Then that has a cable that goes to a patch panel. And then from that patch panel, we literally connect to a switch. That switch connects to a patch panel, and then that panel has a cable going down to the other room to another patch panel, and then from that patch panel we literally connect to the multi-layered switch, which has a cable to the router, which then that router connects back into another patch panel. Alright. And we drew that out in class the other day. So that's it.